Welcome to Get Your FRQ On. This question is from 2005, Form B, Question 2, and it is calculator active. In the question stem, we've got a water tank that holds 1,200 gallons of water at time t equals 0. And then we have two functions, one that gives us the rate at which water is being pumped into the tank, and a second function that tells us how quickly water is being removed from the tank. In part A of this question, we are asked if the amount of water is increasing at time t equals 15 and to provide a reason why or why not. Whether the amount of water is increasing or decreasing at time t equals 15 is going to depend on the sign of the value of W of 15 minus R of 15. Right? We have water coming in and water leaving, and those two are working against each other. So we're going to figure out which one's kind of winning at t equals 15. And since this is a calculator active question, we can use our calculator to find out what that difference is. W of 15 minus R of 15 equals negative 121.09. And what's important here is that that is negative, which means that water is leaving this tank or being removed from this tank faster than it's being pumped in. So because W of 15 minus R of 15 is less than 0, we know that more water is being removed from this tank than being added, so the amount of water in the tank is not increasing at t equals 15. In part B of this question, we are asked to find the number of gallons of water in the tank at t equals 18 to the nearest whole number. The amount of water in the tank at t equals 18 depends on the initial condition in the question and the functions w of t and r of t. That is given by the integral expression, 1200, which is the initial condition, plus the integral from 0 to 18 of w of t minus r of t dt. And since this is a calculator active question, we can use a calculator to evaluate. This is 1309.788. So at t equals 18, there are 1,310 gallons of water in the tank. Recall we were asked to round this to the nearest whole number. In part C of this question, we are considering the closed interval from 0 to 18, and we are asked to determine when in this interval the amount of water in the tank is at an absolute minimum, and to show our work. The amount of water in the tank is going to be at an absolute minimum, either at an endpoint, since this is a closed interval, or some value of c on the interior, such that w of t minus r of t is equal to 0, and changes from positive to negative. So because the amount of water in the tank is actually given by the difference of wt and r of t, it might not be a bad idea to actually define w of t minus r of t to be another function, like say a of t, for the amount of water in the tank. And what we already know is that a of 0 is 1,200, and we've already determined that a of 18 is 1,310. So a of t, or w of t minus r of t, is going to equal 0 based on our calculator, since this is a calculator active question. On the interval from 0 to 18 will occur either when t is equal to 6.4948 or when t is equal to 12.9748. Calculating a of t at these two values, we see that a of 6.4948 is about 525, and a of 12.9748 is about 1,697. Based on this, we conclude that the amount of water in the tank is at an absolute minimum when t is equal to 6.4948. In part D of the question, we are given that for T greater than 18, no water is pumped into the tank, but it continues to be removed at a rate R of T until it's empty. Let K be the time the tank becomes empty. Write an equation involving an integral to find K. We know from previous parts of this question that at T equals 18, there is 1,310 gallons of water in the tank. So the tank will be empty when the rate function R of T, that tells us how fast water is being removed from the tank, removes those 1,310 gallons. So we really only need to integrate the R functions. We're going to get the integral from 18 to K, whatever that value is, of R of T dt needs to equal 1,310. That's when R of T will remove all of the water in the tank at T equals 18. And since we don't have to actually evaluate this or solve for K, this is the answer that we should provide. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.